Perfect. All right.
Perfect. All right. All right, everybody. Well, good afternoon, and thanks for attending today's webinar on how to build the impossible, a case study with Dr. Chau Chak Wing Building at UTS Sydney, designed by Frank Gehry with our Vice President of Design and Distributor Sales, Laura Robertson. We are delighted to work with AIA Iowa with this presentation today and appreciate them allowing us to open it up to all else who are interested in today's topic. My name is Brian Yansak, and I am the Design Studio and Events Coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout the presentation, and they will be answered at its conclusion. Your attendance will be marked, and we ask that you stay on for the duration of the presentation for you to receive your credit. Everyone attending the duration of the course will be receiving a certificate of completion within the next 2 business days, and those who provided their AIA number during registration will be submitted for credit as well. If you're participating today but did not register and did not submit your AIA number, please email it to events@glengery.com. That is events@glengery.com with your information, and I'll go ahead and make that happen for you. Today's session is also being recorded, and a link for you to access it will be provided within your certificate of completion. I would now like to introduce our speaker today, Laura Robertson. Laura is an experienced ceramic engineer with a demonstrated history of working in the building materials industry, specializing in the manufacture, design, and construction of clay, glass, and concrete products. Beginning her career in Australia, Laura has held roles in research and development, technical sales, business development, and national design and specification, collaborating with architects on a number of award-winning projects before relocating to the United States in November 2019. A graduate of the University of New South Wales in Sydney, Australia, Laura holds a bachelor's degree in ceramic engineering and an executive MBA from the University of Technology, Sydney. And with that, I'll turn it over to you, Laura.
Okay, thank you, Brian, for that introduction. And just a little bit on my education history. I loved working on this project and being part of the UTS building so much. I went back there and studied my MBA in this building, so I know it very well. I spent many late nights there and many weekends there, so look forward to telling you all about it today. Okay, so this presentation, just a little bit on the copyright, protected by US and international copyright laws, and cannot be reproduced, distributed, or displayed without written permission of the speaker. Okay, here's the course description. So today we're going to take an in-depth look at the masonry component of the Dr. Chau Chak Wing Building facade. The Dr. Chau Chak Wing Building is the business school of UTS in Sydney. So it is in Sydney, Australia, and I'm from Sydney, Australia, so that's why you're going to have to get used to hearing a funny accent today. I do have that Australian accent still, even though I've been here nearly 18 months. So the project is shaped like a crumpled up paper bag, and Frank Gehry's complex design required the development of 5 special brick shapes produced by the Bowral Bricks facility in Australia. A bespoke wall tie was also developed to secure the bricks to that undulating substrate as the bricks curve in and outwards on the facade. This building has been highly influential, shaping the resurgence of contemporary brick architecture throughout Australia. And we always like to see inspiration coming from projects like this all around the world, and we hope it inspires you in the work you do as well. A few more of our AIA credentials. We're a registered provider with the American Institute of Architects continuing education system. Just a little bit of an overview of Brickworks. So Brickworks is the parent company of Glen-Gery. Brickworks acquired Glen-Gery in November 2018. I believe it was on Thanksgiving Day in 2018, and since then has acquired 2 other manufacturers here in the US, Sioux City Brick and Redland Brick, which has brought our brands in the United States to 4. We also have a large suite of international brands we work with, San Selmo bricks from Italy, La Paloma bricks from Spain, and beautiful Venetian glass bricks as well we bring in internationally, as well as a suite of Australian brands where our head office is located as well. So we're growing to be quite a big group these days, and it's great to see so many different options under the Brickworks umbrella. A bit more about Glen-Gery. So we provide design professionals a whole range of products and also a whole range of different support opportunities. So on the product side, we manufacture face brick, thin brick, structural brick, both manufactured and natural stone we provide. clay pavers, glazed brick, coloured and pre-blended mortar, glass bricks, masonry accessories, and a variety of wall systems. And on the support side, you can come to us if you need any help with product and technical profiles, product development, special shapes, case studies, AIA presentations like the one you're hearing today, wall systems guidance and suggestions, detail review, and specification review and guide specifications too. So we're not just about selling the products, we want to support you to make sure that you've got all the information you need to be successful with your design as well. Having a look at the learning objectives for today's session. So we'll understand and discover how the facade at UTS was designed and constructed, determine how design limitations were overcome with the development of unique bricks, identify the design details for the bespoke brick restraint system used, and describe the design development, engineering, and fabrication of the UTS facade. And lastly, observe the installation and construction methods used on site to achieve this highly detailed brickwork. So looking back over his long and illustrious career, Frank Gehry has designed some incredible landmark projects that define spaces around the world. Many of them have been for major universities and world-class institutions. Frank Gehry has used brick as a predominant material on a number of these. So looking back, you can see some of the inspiration in his earlier work for what we saw at UTS. This is Daniel Zollhoff, the new customs house in Düsseldorf, Germany, completed in 1998. We have the Ray and Maria Starter Center at MIT, opened in 2004. The facade materials here are a combination of angled brick, mirror surface steel, and brightly colored paint. The freedom, daring, and creativity in the design is intended to exemplify the research that occurs inside MIT's historic radiation laboratory. And here we have the Marta Herford building, located in Herford, Germany, dedicated in 2005. For the facade, Frank Gehry chose dark red bricks which stand in stark contrast to the reflective stainless steel roof and plastered white core of the building. The building houses a contemporary art gallery and is described as one of the most unusual museum buildings in the world for its curved and angled brick forms. So we can see that Frank Gehry has completed some innovative and contemporary brick buildings around the world. Here in Gehry Partners were appointed for their first project in Australia. We couldn't wait to see what they would come up with. This was the first sketch of the UTS building from Frank Gehry, which was eventually developed into this. When these images were first released in early 2011, we saw these drawings and we thought, you can't build that out of brick. But as we've seen, Gehry's designs push materials to their limits, and this building is no exception. Referred to as a treehouse, so Frank Gehry refers to this building as a treehouse. I hear it more often described as a crumpled up paper bag or maybe a haunted house, but he calls it a treehouse, a growing learning organism with many branches of thought. Inspired by a treehouse, the stacked undulating design of the building features two major facade materials. On the glazed western face, which is at the rear of this building, there's large angled sheets of glass that fracture and mirror the image of the surrounding buildings. And they literally mirror all the brick buildings in Ultimo, which is a very historic area of Sydney, which is predominantly brick, and it will mirror those literally on that surface. And then on the curved brick exterior, you see on the other surfaces, the building is designed to reflect Sydney's urban brick heritage. The central spaces are free from columns to create open, collaborative spaces for students and staff, punctuated by sloped columns around the building's perimeter. Here you can see some more of those early drawings from Gehry Partners. These drawings were released back in May 2011. At this point, they hadn't figured out the exact details of how to build this facade, how to attach those bricks to the structural frame, and how to restrain the bricks as they cantilever in and out. DJRD were appointed the project architects in Australia on the job, and these were the first images they released. We were all thinking, you can't build that out of brick. But by collaborating together with the Australian and American teams and a whole range of different experts around the world, we had to figure out a way to build this facade. Frank Gehry's inspiration was from the colonial style surrounding brick buildings, and the decision was made to go with brick to reflect the history of the area. And also the color was selected to reflect the color of the Sydney sandstone, which is heavily prevalent in a lot of the convict areas in historic parts of Sydney. To quote Gehry's design intent, the east-facing facade is made of a buff-coloured brick, similar in colour to the Sydney sandstone. The form of the facade curves and folds like soft fabric. The brick will be set out in horizontal courses and will step or corbel to create the shape. The texture of the surface will be rough and will emphasize the mass of the material. The shape flattens as it wraps around the north and south corners, and large windows punch this facade. So we'll start out with a few facts about the building. So it was the first project in Australia designed by Frank Gehry. It is the UTS Business School City Campus, so it's located right in downtown Sydney. The building is named for Dr. Chau Chak Wing, who donated $20 million to the project. His son actually studied at the UTS School of Business, and he was so pleased with the education his son received, he decided to be a major benefactor to the university, and he's got his name on the building for that reason. UTS sought Frank Gehry for his development of these creative spaces. As we've seen, he's an architect who embodies this contemporary approach to design, and they wanted the business school at UTS to really stand out as a contemporary business school. So they chose an architect who could design something highly contemporary that could be marketed on the world stage. And that's been highly successful for UTS. And I can say it definitely attracted me to study there myself. A.W. Edwards were awarded the construction contract for all of those pre-construction services. So that was for the procurement of the facade subcontractors, expression of interest for a two-stage procurement process associated with those facade elements, and a comprehensive proposal including a budget estimate. Once it went to construction on site, Lend-Lease were awarded the construction contract, but A.W. Edwards were doing all of this pre-construction work before it got to site. So included in that was the detailed development, design, engineering, fabrication, supply, and testing of the facade. They were looking at curtain walling systems and whether it would be a steel or a timber support structure behind that. Wall substrates, rain shields, and waterproof membranes where they were required, window boxes and the framing and cladding of those, obviously the masonry component and the punched window glazing. So this was the procurement timetable. It was a very short timetable for such a challenging project. So over the 8-month period from May 2011, from the expression of interests back in May 2011 through the commencement of shop drawings and procurement, it was an 8-month process where they had to resolve all of the engineering, fabrication, and installation of those facade elements. So everyone was working at lightning pace to make sure that this project turned up on schedule and made sure they met these tight deadlines. So this is the team that worked on the project. It was really a collaborative effort through a whole range of different organizations. So obviously we had Gehry Partners leading the project from the US, and this is the Australian team on the project. So Daryl Jackson, Robin Dyke Architects, headed up by Robin Dyke and Daniel Beekwalder, led the project and project architecture from Australia. Arup were the facade engineers on the project, with ACOM engineering specifically the brickwork. Pavetti were awarded the contract for the bricklaying, and it also included sales, technical, and production staff from Brickworks. So back in May 2011, many different construction options were being considered. As we said, they hadn't exactly figured out how this building was going to be built and designed and constructed, so many different options were being considered. So at that time, they were looking at brick tiles, precast panels with a brick inlay, brick veneer on a precast structure, or a folded metal facade, and the pros and cons of each system were investigated. So we'll take a look at a few of those different options that we considered and why they went down the path that they did for this project. So the first concept was the use of a steel stick and frame. So the concept here, you have thin individual brick facings that are mechanically fixed to some kind of rail system. So the challenge for using this technology was that the brick tiles need a high number of fixings to secure those sloping walls. So the walls aren't perfectly straight up and down, they angle and curve. So any sort of traditional rail system's really well suited to maybe really subtle curves or subtle angles, but not the degree of corbelling and angles that were required for this project. So they liked this idea because it would reduce the weight of the brickwork on that substrate. So they wouldn't need to engineer that frame to support such a heavy weight, but the engineering that needed to go into fixing all of these individual bricks and designing a bespoke support system that would allow each of these brick tiles to be supported wasn't feasible for this project. So that option didn't end up going ahead. So the next option they looked at was the use of precast panels. So you can see here, the concept that shows a precast panel with the bricks embedded in the face of the panel, and the panel being curved to support the curves and angles of that brickwork in the building. But again, there were some challenges with using this technique. So because this building has very few straight walls and rectilinear junctions, there would be a lot of different width and different size panels that needed to be craned into place. And those curves that corbel the brickwork outward would make those panels quite heavy. There was limited capacity from the crane on site as well, which meant the panels would need to be smaller to be able to be supported by the crane on site. So that would have created a patchwork effect where there's lots of small panels that needed to be connected, and you would have really seen a lot of joints on the project. Also, one of the main benefits of precast, if you've designed with brick in precast before, one of the main benefits you can get in economies of scale is replicability, where you can use the same mold or the same form liner many times to achieve your design. On this project, there would have been no two panels the same size, the same shape, no two forms the same. So it would have been very expensive to do this job in precast because there was no replicability of those panels either. So for budget reasons and also for aesthetic reasons, they didn't end up going with this method. But having a look at brick face precast, it is a very popular type of construction, particularly for when you want to do projects that have limited time on site. So you really want to maximize your construction capabilities on site, get through your installation very quickly. The panels simply get craned into site. A lot of the work is done before the panels even get there. So it limits the amount of work on site. But it does have some limitations in terms of those curvatures and custom mold liners required as well. The next concept they were looking at was the use of thin bed mortars. So thin bed mortars are not common in Australia, and there was nothing at the time in the Australian standards that allowed for the use of thin bed mortars in commercial construction. But it is quite a popular technology in Europe, and still an emerging technology in the construction market for brick. So essentially the bricks are glued together with a polymer modified adhesive in the joints that allows for you to really decrease the size of your mortar joints down, and creates a strong bond of the bricks between each other because there's that additional adhesive element in the thin bed. But because there was no Australian standard to be able to use thin bed mortars, they didn't go ahead with that technique for this project, but it could be something we see more of in the future. The next concept that they liked the idea of was the use of robot laid bricks. So robotics in the brick industry is still a really emerging technology. It hasn't really reached the point where it can be used commercially for large scale projects, but there have been a lot of smaller prototype projects that have been done over the years. You can see Rob the Robot there at the Venice Architecture Biennale in 2012. So that's coming up to 9 years ago now that the robot was demonstrating how you can lay walls with robotics. And what's great about using robots to lay your bricks is they can work 24 hours a day. They can lay with a really high degree of accuracy. They can design it exactly to your, lay your designs exactly to your plans, and they don't complain, which is great, but that's still not commercially viable for large scale projects. But there are a few prototypes out there. I know a lot of the universities are doing work on robot laid brickwork, and it's something we expect we'll see a lot more in the future. You can see that the Hadrian robot, that's a Fast Bricks Robotics project in Perth in Australia. Those are really good at laying out long straight runs of brickwork rapidly, so you can basically have the truck turn up on your site and it'll lay the bricks in your house for you, and it can work quietly and around the clock to make sure your projects are finished accurately and in a much shorter time frame. You can see Flight Assembled Architecture laying brickwork by drone. Again, drones can lay with a high degree of accuracy and reach areas where it may be really challenging to get to otherwise. So up on steep cliffs and elevations where it would be unsafe to have humans working. So we're likely to see a lot more of these technologies as the price of robotics continues to go down. and the price of labor continues to go up, we'll be likely to see a lot more of this robotic laid brickwork in the future. So by having a look at all those different options, what they realized was it would need to be a solid brick that was laid by hand. So now the challenge becomes, what are the limitations of solid brick? How far can you corbel the brickwork out above the bricks beneath? And if you have a cored brick, what happens if you have corbelling and you see core holes in the brickwork? They really didn't want to see that. And then curving the brickwork. What are the minimum and maximum radiuses of your curvature to make sure you're getting a nice smooth effect? So if you have a really tight radius and a long rectilinear brick, you can end up with this wide opening up of mortar joints, which changes the look of your brick to mortar ratio on your wall and can look very unappealing. So now it becomes, if we're using a standard brick, what are the limitations and how do we design to make sure we have the most effective outcome? The brick that was selected by Gehry Partners was an American brick, a jumbo size, 11.5 by 3.5 by 3 inch unit called Summer Wheat from a manufacturer in California. There were 22 special shapes in the original design, and Gehry Partners had proposed that all of these bricks be imported from the US. But UTS actually insisted on a local manufacturer for the bricks. They'd seen that the majority of materials in the project were already being imported from China, and they required an Australian manufacturer for the brick. So that's at the point where Brickworks in Australia got involved to make sure they could meet the requirements of Gehry Partners and match that summer wheat brick that they wanted to see. So many different trials were done looking at solid and extruded bricks, bricks of different widths and different core patterns, and of course different shapes. And colors were produced in factories all around the country and submitted as options. So you can see here some of the attempts to match that summer wheat. That's the summer wheat brick there. You can see a few of the matches to get close to that brick. In the end, it was determined that a solid brick would need to be used. They couldn't have a brick with core holes in it. It needed to be a brick that was visually appealing on all surfaces. So they settled on the Bowral Bricks factory that produces dry press bricks, as they needed something that would be good, that could be used on all surfaces and have those beautiful finished faces. As parts of that building, show the sides, the base, the top, and the front of the bricks in some areas, they needed to make sure that that brick was as beautiful on every surface as it was on the face. Here you can see some of Gehry Partners' early designs looking at the different corbelling angles in the building. You can see in their modeling, they've modeled the angle out to 31 degrees in some places where the brick corbels out above the bricks below, and in both directions, so outwards and inwards. So the geometrical complexity of that brick facade required extensive 3D modeling and experimentation with various means of construction to make it happen. Gehry Partners undertook detailed 3D modeling to check the placement of each individual brick in this facade. Here you can see some of the cuts modeled for the project as well. So here they're looking at where they can cut the brick to achieve the angles and curvature in that facade as well. So you can see some of that there. And some of the early drawings for the special shapes required for the project. Bricks of different lengths and different angles, really being a priority for this project to achieve Gehry Partners' vision. While Gehry Partners were working on all of that, the bricklayers in Australia were also doing some trials to check whether what they'd seen of the project was actually possible. So at that point, they were doing some trials to check the curvature and corbelling limitations. And what they realized by going through this trial process was that traditional masonry restraint systems could not be used, and special wall ties would need to be developed if they really wanted to corbel and angle the brickwork out as far as they do in this project. You can also see some trials here looking at the curvature of those walls as well. So that's what we mentioned earlier, where if you have a tight radius and you're curving the brick around, you get this opening up of those mortar joints. So that's not a very appealing look. So we recommend either moving to the header of your brick, so rotating it around and using the header, using a brick with a smaller face, or we also produce radial bricks and curved bricks that have the curve in the face of the brick itself, so you can end up with a very nice smooth curve too. And having a look here at the convex angle, For a very small radius, you can end up with this overlapping effect, which creates shadows at different times of day. So again, you can get a radial brick with a concave curve on the face of it to make sure those curves are nice and smooth for you as well. So originally in the project, there were 22 different special shapes designed by Gehry Partners. That came down to 5 special shapes. From a custom American color, the summer wheat, it came down to a standard Australian color. And from a custom American size, it came down to a standard Australian size. So they went through the value engineering process and decided they really still wanted to use brickwork, and they wanted to have a lot of special shapes and have the details that they wanted. But by changing the size, changing the color, and compromising on the shapes, they're able to significantly reduce the budget of the project. So that's the reason why there were fewer shapes than were originally designed. So finally settling on these 5 customized bricks. So having a look at them, each of those bricks, you can see they have this continuous central rebate. So the brick is a solid brick that has this long channel running through the length of the brick. The second shape there you can see also has that central rebate, but it's offset 25 millimeters or roughly an inch from the edge of that, at the rear of that brick. You can see the L brick, which was wider than the standard brick, with this L lip shape that overhangs the shelf angles of the project to conceal those shelf angles, and also reduce the horizontal expansion joint down to really reduce the size of those expansion joints and make sure they're less visible. Next, we have the solid brick, which is solid on all surfaces, finished with 6 faces. So no frogs, no core holes, no indentations, just a solid brick. And lastly, the K brick with an offset rebate. So this brick has an angle, 103-degree angle on one of the faces of it, which is designed to look as though, to appear as though it's been twisted from the other bricks in the course. But it's actually just designed to appear that way with this angle in it. And that central rebate that aligns up with the other central rebate bricks that we've seen. And I'll show you why that rebate was necessary as we get through the presentation. So looking at those special shapes, you can see 4 of them here. We've got the centered rebate, the K brick, the offset rebate, and the L brick, with the 5th shape being that solid brick with finished on 6 faces. And a 1/3 bond pattern was adopted for the wall to suit the curved nature of those walls and avoid the lining up of a strong vertical bond pattern. So by utilizing a 1/3 bond, you can more easily disguise where you have cut bricks, because it sort of hides in that bond pattern. It doesn't repeat itself as regularly as a standard stretcher bond. So it really allowed it to move more with those curves and avoid the appearance of any cuts or different sizes in that bond. In order to make these bricks, special dies were fabricated. Here you can see the die box for the K brick and also for the L brick there. These were made of case hardened steel. The factory that produces these bricks is a dry pressed factory, and all the shapes are made in hydraulic presses. So these dies can be used about 250,000 times per brick. So they can be used over and over and over and over again due to that case hardened steel. And then if you need to use them again after that, you just replace this piece inside the die with a new liner, so you can keep using it over and over and over again if you want to use that shape on another project, or if you've got large quantities of brickwork in the project. You can see the bricks coming out of the kiln. They're being graded here for size and color to make sure that they're meeting the Australian standards. And that's the limousine gold color there, that's like a sandy golden color that Gehry Partners selected to look like the Sydney sandstone. So a few more facts about the building. The total area was 16,000 square meters, or 172,000 square feet over 12 levels. 380,000 of those gold tone bricks were manufactured for the project, with 5 special shapes, and the testing undertaken on the bricks was extensive to meet the high expectations of Gehry Partners. So we're testing things that you don't typically see a brick being tested for. breaking load and earthquake resistance, and a special jump test that was done for Gehry partners as well. So there's no Australian standard for what Gehry partners were concerned about was abseilers climbing down the building and cleaning the windows. So they would know that they would need to have abseilers climbing down to make sure that those windows were nice and clean. And they were concerned about edges of the bricks crumbling off as those cleaners are coming down the building. Now, of course, there's no test or standard for that. So what the team at AECOM engineers did was get a few of their contractors with steel cap boots on to jump on the edges of those bricks over and over and over again to make sure that those corners didn't knock off and there was no breakage on the edges. And it was very effective and the bricks did not crack or break. So we call that the jump test now, and we can perform that test for anybody who needs it. Having a look here now at the structure, so there's only one straight column in the entire building. I believe it is this one, although the photographer might have been leaning a bit while they were taking that photo. Every other column in the building angles in some form, so there's always this sort of angled feeling as you walk throughout the building. Here you can see that substrate wall. So it was a steel frame substrate prefabricated in China and shipped over. This included the membrane and the wall tie attachments. So you can see that those substrate walls were individually numbered to indicate their position in the facade. So like a paint by numbers showing where each different panel would go to make sure each one ended up in the right place. Here you can see that substrate wall as it's being installed. So this is having a look at it from the inside, looking out. You can see it's substantial substrate designed and tested to carry the load and the weight of that brick facade. So there's another shot of that. It's a galvanized steel substrate frame. Again, designed and tested to carry that load and weight to make sure it would withstand the weight of all those heavy bricks on that outside facade. Coming around to the outside of the building now, you can see that substrate wall as it's being installed with that waterproof membrane sealed at the penetrations to ensure no water transfer through that substrate. And these are all the different wall tie attachments. So by installing the wall tie attachments in that substrate wall, it made it as easy as possible for the bricklayers as they're coming along and laying the brickwork in each course. They just need to look back and see if there's a wall tie attachment on the substrate wall in that place. They know they need to install a wall tie in that position and tie the brickwork in. So they don't need to do any calculations of number of wall ties per square foot or number of wall ties per course of brick. They just need to look back and see if there's a wall tie in that position, they need to tie it back in that place. So the bricklayers had a real challenge here, laying the intricacies of the curvature and the highly detailed brickwork in the facade. So this was one of the things that was designed to make it a little easier for them as they're working through that installation. Shelf angles were used to support the brickwork at each floor. So here you can see those shelf angles coming off the slab edge on each level of the building. This is one of my favorite shots. You sort of stand underneath the building and look up and see how it curves above your head. Having a look there, you can also see those window boxes. So there were no two window boxes in the project that were the same. Each window box was purpose-made, bespoke, and at different widths and different angles coming out from those internal rooms as well. So everything in this project was custom-made and special just for UTS. One of the biggest challenges on this project was how do you restrain both projecting and receding brick walls? So we had to work together with AECOM engineers to be able to produce a brick that could be tied back and secured to this substrate. So you look at that building and you see those bricks curving inwards and outwards, and the biggest concern is what happens if a brick falls on someone and hurts somebody. So we needed to make sure that these bricks were properly restrained to make sure that it would be safe for people to walk in and around and underneath that building and never be at risk of any injury. So we saw earlier that those brick shapes were designed with that continuous central rebate. So having a look at it in plan here, you can see that that central rebate lines up with the rest of the brickwork in the course. with that continuous slot that runs throughout all of them. And here you can see it in section. This was one of the sketches from ACOM in September 2012. Quick sketch that they did showing how this brick tie would sit in sections. So now we're looking at that central rebate from side on, and that wall tie sitting inside that central rebate. So has this clip that secures back to that wall tie that we saw on the substrate. So it ties back to the substrate at this point. And then it has this clip that sits inside that central rebate. We have a continuous rod that sits inside there, that sits inside that central rebate and locks in place with this wall tie. And then a threaded washer that gets screwed inwards or outwards at the back of that brick to make sure those bricks don't fall inwards or outwards during installation. So essentially, this one wall tie could be used for every brick in the building, and make sure that they're secured to prevent any slippage or moving of those bricks. So having a look at it there now, this is a key innovation. They call it a clip and tie system that held those bricks in place during construction. It also provided the necessary tolerance to enable that curved geometry of the building to be achieved. So it's allowing for that cavity width to be determined by the wall tie, and also screwed inwards or outwards if they need to correct that cavity width distance, and also allow for different curvatures in the building. You could always use this one wall tie in any place. So a plate goes into the back of the brick when the brickwork corbels in, holding it from falling. So it's an innovative little wall tie that could be used in any place throughout the building. Here you can see where those L bricks were used. So in the US, we call this a lipped brick. In Australia, they call it an L brick, but essentially it's the same thing. It's a wider brick unit that was, the engineers required a 90mm or 3 5/8 bearing on that shelf plate. So it's a little bit wider, as you can see there, than a standard brick to allow for that additional bearing. And then it has this L piece that hangs off the end of it to conceal that shelf angle. So you're not seeing that shelf angle. It's not creating a visible obstruction in that facade that really stands out, and helps reduce the size of that control joint too. So what would have been a 2-inch control joint reduces it down to 1 inch, so that it really is much less visible. If you had these big 2-inch joints throughout the building, you'd really notice where all of those different slab edges sit in the building, and it'd be very obvious. So by using this L brick, you can conceal that and make that brickwork look more continuous throughout the height of the building. Another detail showing that L brick. So a little bit about the brick specifications. So an exposure grade brick was required for the project. That refers to a brick that can be exposed to aggressive environments. So if you're building within 1 kilometre of a surf coast or 100 metres of a non-surf coast, particularly important for brickwork in Australia, where almost every city in the country is very close to the coast and very close to surf areas too. So salt attack is something that is always a challenge. In the US, we worry more about frost attack, but in Australia, salt attack is a big concern. Dimensional classification DW2, which is dimensional tolerance equivalent to a type FBX in ASTM standards, required a minimum compressive strength of 8 megapascals, equivalent to around 1250 PSI, so a relatively soft brick, grade NW. Cold water absorption less than 10%, no lime pitting, and no efflorescence. So these are pretty standard brick specifications. If the brick has lime pitting, that's usually seen as a flaw, and same as efflorescence as well. Usually indicates there's salt in your ground clays or shales used to produce the product. So a good quality product won't have any lime pitting or efflorescence anyway. So pretty standard brick specifications that you see on the majority of projects. There are also very strict requirements for the mortar. So it was an M4 mortar, which was pre-bagged for quality control, most equivalent to a type S mortar that you'd see here in the US. 10 mil or 3/8 of an inch joints, shallow ironed to 2 to 3 millimeters or 1/8 of an inch ironed. Bricks laid out in a 1/3 running bond with R4 ties and shelf angles. Again, that's a durability requirement related to salt attack. Masonry shall be built to the tolerances set out in the Australian Standard 3700. And the tolerance of position in plan. So this last brick specification is one that you really don't see on a lot of projects, and maybe only Gehry partners could get away with it. But the tolerance of position in plan of any point on the fair face from the location indicated in the architect's 3D database shall be plus or minus 15 millimeters, or 5/8 of an inch. So every brick in that facade needed to be within 5/8 of an inch of what Gehry partners had designed, or those walls were coming down and the bricklayers were starting again. So in the early days of the brickwork being installed on this project, a lot of walls were coming down as meeting this very tight tolerance. It was very challenging, especially when the brickwork in the project is so highly detailed. So they had very highly skilled masons on the project, and to make sure that they were getting all of those bricks in exactly the right spot, the bricklayers on average ended up laying only 80 bricks per person per day. So it was a very slow process, making sure they were all accurate, but it did result in a beautiful outcome for that project. So 80 bricks per day is it's a slow going. Full scale panels were constructed for prototyping. So you can see the first ones here at a warehouse in Alexandria in Sydney, and then also in China for structural and weather testing to AS4284. Full scale walls were tested in China. So we sent the bricks over for that. And for Vetti, the bricklayers sent their bricklayers also over there to build the walls to make sure that they were all built to Australian standards, along with the substrate and those window boxes that were already fabricated in China. So all that testing was done to make sure that they would withstand the strict requirements for this project. Extreme control of the mortar was also necessary for the project. So there was a requirement in the specification for compression tests to be done every day for the first 30 days, and then once a week, once consistency had been demonstrated. So they would produce a cube every morning for testing, for compression tests, to make sure that it achieved 13 megapascals and had the strength in the mortar every day. They also did flow tests to check that the mortar was not too wet or too dry. So you can see that flow test here. Essentially, they're putting a kilogram of mortar in the center of that flow plate, spinning that flow plate around and around and around and around until it spreads out to the edges of the plate. And that allows them to measure the viscosity of the mix to make sure it's not too wet or too dry each day. So very strict control of the mortar for this project. The mortar was also pre-bagged for quality control to make sure there was no moisture in the sand. The sand was sent to Cement Australia and kiln dried and pre-bagged. So if there's moisture, different moisture content in the sand in your mortar, you can see subtle color differences once those mortar joints have dried. So by making sure there was absolutely no moisture in the sand, kiln drying and pre-bagging that sand allowed for a really, really consistent color across the mortar throughout the building, and mixed at a ratio of 4.5 to 1. Next, you can see the water for the mortar was highly controlled as well. So to minimize site errors, the water and the mortar additives were combined prior to batching. So produced in these 1,000-litre IBCs, so around 264-gallon IBCs, water plus 3 chemicals. So they added Polyhead, Riomac, and RioCure, which were used for strength to minimize dehydration and to reduce drying. So adding these chemicals into the mortar made sure that they had high quality mortar for the project. And it's probably the only time that I've ever seen bricklayers with test tubes on a site, measuring out those chemicals to make sure they had the right composition in their mortar as well. And then what they'd come along and do would get 1-gallon jugs of that liquid per batch of mortar. So they're making sure that the ratio of water, sand and cement in their mortar each day was always consistent and always the same. Having a look at the bricklaying now, so the bricks were individually dipped in water before laying, so that allowed for a slight surface coating of water without saturating the bricks. So these bricks were a dry pressed brick and they have very high absorption. So on a hot day, they would suck a lot of water out of that mortar as it's being laid, and that could result in cracking or reducing the strength of the bond between the brick and the mortar. So by individually dipping them, they're making sure they're not oversaturated, but also have that nice surface coating so they're not sucking too much water out of that mortar as they go through the project. The bricks were cleaned with an industrial vinegar and light pressure. There was no acid to be used on site, so the industrial vinegar they used achieved a beautiful outcome. But I think also part of the reason why the brickwork looks so good is because they were laying them very slowly and cleaning as they went to make sure that they had beautiful clean joints and no smearing of mortar on that brickwork. Here you can see some shots of that brick restraint system going in place. You can see that wall tie sitting inside that central rebate of the brick and fixing back to the substrate at that wall tie attachment point in the substrate wall. Another shot there showing that wall tie sitting inside that central rebate with the rod that runs through the central rebate in the brick. And on the right there, what will be a vertical control joint. Again, a few more shots of the brickwork being installed. These are those L bricks that are sitting on that shelf angle. So you can see that L brick going into place and nicely concealing those shelf angles so you can't see it in the project. And there on the right, a sawtooth angle as those bricks come together and create a jagged joint, which looks a bit like a zipper as it goes up the wall. Interesting joint choice, really stands out on the project. Mortar net was used in the cavity at the base of each level to prevent mortar from blocking the weep holes and providing drainage. So by installing this at the base of each level, if mortar does drop behind the brickwork as they're installing it, it allows for additional pathways for that water to drain out of that cavity and prevents any mortar from blocking the weep holes so that you still can drain out water, and it'll also allow for equalizing pressure and drying that cavity as well. So a handy little product that was installed at the base of each level. Here you can see the bricklayer coming along and tooling off those joints. Beautiful clean brickwork as we were discussing. They were cleaning as they went and made sure that the brickwork was high quality throughout the project. And the bricklayers were so proud to work on this project. This gentleman was so proud, he got it permanently tattooed on his arm. You can even see the little K bricks that are shaded to look as though they've been twisted out of the course. We now know they're designed to appear that way, but he's got them sort of shaded on his arm like that. And by having that on his arm, it's also almost like having your resume tattooed on your arm. By working on this project, these bricklayers could get a job on any brick project anywhere around the world. It was such an iconic building and such an amazing testament to the, the artistry of well-laid brickwork that it's like having your resume on your arm, and it can get you a job anywhere, any project you want to work on. Very, very impressive work from the team on the job. So here you can see those two factors on this project that make the building unique. We've got the corbelling that corbels out to 31 degrees in some places, and those K bricks that are offset and give shading. So at different times of day, create different shadows on the building and appear as though they've been twisted from the other bricks in the course. A few shots of those internal spaces. You can see this is prior to the university opening. It's a very modern university with these collaborative spaces designed for students and staff to collaborate and work, study and learn in a modern way. And this here is Cafe 80. This is prior to the cafe opening, but really nice bar and cafe on the lower level of the building that again replicates those curves and folds that you see in the facade in those internal areas. And Cafe 80 was named after the average number of bricks laid in a day by each bricklayer. 80 bricks, Cafe 80. A nice bit of brick trivia if you ever get quizzed on that. A few more shots of those internal spaces. So they're really curved to create these collaborative spaces for students, and has this unusual shape as you walk through it. You'll see those angled columns as well, and those window boxes where you can sit inside the window box and look out and admire the brickwork, or look down at what is the goods line, a beautiful public park that runs from Central train station in Sydney through to Darling Harbour, through the harbour. So quite a nice walk. If you're ever in Sydney, I recommend walking along the goods line and admiring the beautiful Dr. Chau Chak Wing Building. So that's the completed building as it stands today. So from the original design, by reducing the number of special shapes, it did sort of smooth out some of the crumples in that paper bag. It's not as crumpled as it originally looked, But it is a spectacular building. And right when the scaffolding was coming down, and every day since, whenever I'm in the area, there's always people staring up at it in awe and taking photos. It's really a remarkable building, and it's definitely been an inspiration for contemporary architecture throughout Australia and around the world. Now I just have a short video that shows the building once it was opened. So see if I can play that for you now.
When I first saw the drawings of the Gehry building, I just said that can't be built out of brick. It looked like a squashed paper bag, a crumpled paper bag, and with the undulating folds that were in the drawings, I thought there's no way you can build that out of brick. From what you know about Frank Gehry buildings, when you see them, you know that he pushes materials to the limits, and he does things with materials people don't do. So when I saw the drawings of it, you knew that it was a Frank Gehry when you looked at the drawings, and he was pushing brickwork to its limits to try and do something different with it.
Describing the building is very difficult in words. It's probably best done by using images and pictures. In this project, Frank Gehry has designed a brick building unlike any brick building that's been designed before.
I was terrified, because of the shape of the building. I never built in things like that in my life. I've been doing a lot of arches in my life, which is arches is not a normal. I've been doing a lot of round wall, which to me that's a normal, but this shape is not a normal.
We were aware of the work of Frank. In fact, some of the designers in the office had done previous projects with Frank, so we were definitely aware of the challenges entailing the work and the vision impressed by Frank.
After many trials of making bricks all around the country at our various plants, we ended up selecting Bowral to make the bricks. Bowral was selected because we realised in the process we needed solid bricks.
When we found out we were awarded the project, we were extremely excited. It was always going to be a challenge, but Bowral has prided itself on being able to do the extraordinary when it comes to serving the needs of our architectural clients. Bowral has always had the ability to make special shapes to suit a lot of our architects' needs. It was definitely a difficult job, and we believe we've done an exceptionally good job producing the product.
Now that the project is nearing completion, I can see the vision that Frank Gehry had in terms of his design and the outcome of the building. It's art, that's been constructed up there. You can tell that the time that everyone has spent on this project, all the team members, has all paid off.
Every time I go past it, and I always drive down and do a detour down Mary Ann Street when I'm driving through the city just to see how it's going. It's an amazing building, and it's going to be an inspiration for architects for years to come.
I'm very proud of this building. But to build something like this, you needed to, it is a lot of challenge.
To have something of such high calibre and profile to be done in brickwork, it deserves recognition and congratulatory.
I think the building's absolutely outstanding. I've had a visit to the building prior to its completion, and the street was full of people that were in awe of the design and the uniqueness of it. It's obviously something that we're going to be very proud of for many, many years. We've managed to do what a lot of people thought was the impossible.
Okay, that wraps up our content for our session today. So now we'd like to open it up to you for questions. Brian, can you remind everyone how they ask questions?
Of course, we have a couple coming in. It's the Q&A function at the bottom there. No need to raise your hand. You just go in and type in your question.
Okay, great. I can see a couple of different questions coming through. So the first one I'm seeing from Patrick. What type of alluvial clays and shales make up the brick mixture? The texture brick seems to resemble American fire brick. Okay, that's a really interesting question, Patrick. And I would say that it's a different type of brick than what you typically see in the US because of the different geology, I suppose, of what you get in Australia. So it's a dry press brick and it's predominantly shale. So finely ground shale that's compressed into shape rather than extruded with moisture like you would see in a typical clay brick. So typically shale that is used to produce those dry press bricks, which gives it a sandy texture that has a different sort of look and feel to what you would typically see here. So good question. Thank you, Patrick. Okay, so we have an anonymous attendee. The details don't show weeps where I would expect to see them at the membrane above the lintels. Where are the weeps and vents in the system? So the weeps and vents were between those L bricks. So where the L bricks were used above the shelf angles, you had a waterproof membrane below the L brick. And then the weeps were between those L bricks with that mortar net used between them. So to allow the moisture to drain out of the cavity, and that's where you would see them. So at every level, in line with the slab edge, between and below those L bricks. Okay, we have a question here from Joe. How did they deal with the control and expansion joints? So I would say there would be a more significant number of control and expansion joints on this project than what you would typically see, but they were tinted to match the brickwork, so they're not as visible, but they're typically lining up with, and I'll see if we can go back to that. Yeah, you can see at each level, those horizontal control joints there are at every level of the building lining up with the slab edge. And then we have vertical control joints that line up with the right edge of every window. So you can see those control joints are at the edge of every window as well. So there are a lot of control joints on the project, but they are sort of disguised to align with either the window or with that slab edge there. Okay. Another question from Patrick. The K brick, were they placed randomly or laid out in the plans and prints? They were, each individual brick was planned out on where it would be in that facade. So Gehry Partners modeled the position of each of those K bricks and made sure they were all in the right spots. So not randomly, all meticulously designed and planned out and modeled by Gehry Partners. Mark had a question about how the exterior wall was insulated. Was that part of the prefabricated panel? Yes, that was part of the substrate system, insulation included in that. Another question from Mark, how many bricks per day is normal? Australian bricks are a little bit larger, so I would say on a typical project about 300 or 400 bricks per day would be normal depending on the complexity of the project. But you can see 80 bricks per day is a much lower productivity than what you would see on a typical commercial project. Not a question from Eric, but thanks so much, saying these are always very interesting. Thank you, Eric. Oh, Jacob, you're testing my math. You said they laid 80 bricks per day and there were 350,000 bricks on the project. How many bricklayers did they have on the job, and how long did the bricklaying take? They had a crew of about 8 or 10 bricklayers. And I'm not sure exactly how long the bricklaying took, but I figure I could do the math on that. 80 bricks per day. Let's say they had 8 bricklayers. 80 divided by 8. I'm getting about 500 days, so that can't be right. They must have had 10. So. Just at a guess there, Jacob, from what I saw when they were on construction on site, probably took about 6 months to lay the brickwork on this job. Question from Mazan Architects, how would it work in hot climates? Any cooling effect? Wondering whether that's asking about the mortar net, which was installed in the cavity. Yes. It also got used for the Australian Embassy in Thailand as it helps ventilate the cavity. So in climates where there's a lot of moisture and humidity, making sure that those weep holes aren't blocked and you can ventilate moisture in and out of that cavity is very important. So yes, very important in hot climates, and very important where there's high degrees of humidity as well. Question from Lee, does the climate in Sydney require a frost-proof brick and mortar? No. So we don't have frosty weather in Sydney. The coldest it gets is about 40 degrees. So not a requirement in the Australian standards, but something that's absolutely required here in the US. Can you please, I got a question from Hanif. Can you please repeat the corbel dimension and did you load test? The corbel dimension, so it was 1/3 corbel and it corbelled out to 31 degrees in some places. And yes, that was load tested. So they prototyped those walls and load tested them to make sure that they would withstand the pressure of the weight above. So yes. Okay, I've still got a few more questions. I see one here from an anonymous attendee. How is the top of the wall detailed? Is there a cap flashing on top? Yes. So on levels 8 and level 16, I believe, they have these balconies and outdoor areas. And at the tops of those walls, the brickwork is capped off with a cap and a flashing beneath it. Another question, I've got a question here from Lee. Really enjoyed seeing the details as part of the presentation. Are additional details available to view and learn more about detailing unique brick systems? Yes, so we've got a team of technical experts. We have quite a number of case studies as well that we've done on unique projects, special shapes to meet a range of architects' needs. So tune in for some of our other sessions to learn about unique brick design, or if there's a particular question you have for one of your projects, reach out to your Glen-Gery representative and we'll be happy to help you out. We have lots of technical experts and we love designing in brick. We're really passionate about beautiful brickwork, so we're always happy to help you out with any project. Okay, and I believe we are out of time. It's after 2 o'clock, so we will have to wrap it up there. Thank you everyone so much for attending. If there are any questions I missed, I'll try and get back to you on email. But thank you so much for attending today's session. Brian, anything else we need to wrap up?
No, that's it. Just a reminder that everybody that participated will get a certificate of completion in 2 days. If you did not submit your AIA number through registration, please email events@glengery.com with that info. I've already had a couple come through. And just a reminder to join us on our next webinar on water penetration in brick veneer on Wednesday, February 24th, same time.
Thanks everyone for attending and have a great afternoon. Take care. Bye.